All right, so we're going to just write down an approximation for E. E is like pi in that it goes on and on forever and doesn't repeat a pattern. So it kind of looks like it repeats a pattern, but it actually doesn't. So on your paper, this is what is E? E is an irrational number. Whoops, let me spell irrational right. With an approximate value of 2.7182812828. Now, it looks like it's repeating a pattern. It's not. Like the next two numbers are 4 or something like that. So it's going to keep going. It's not going to repeat a pattern. And E often occurs the base of exponential logarithmic functions that describe real life situations. And we'll get into some of those real life situations next week. So money can grow exponentially with E as a base. So can bacteria. So anyway, it's a really common base. Bless you. Now, the exponential functions with a base E are called natural base exponential functions. And an example is f of x equals e to the x. So when you see E, it's about 2.78182. So it's between 2 and 3, a little closer to 3. There is an E button in the calculator. So E in the calculator, there's two places actually. All right, there, if you want to raise E to a power, which we normally actually do want to raise E to a power, what you're going to hit is second and then Ln. That's going to be E raised to a power. And if you look at the calculator, most of you don't have one right now, but if you look at it, above Ln in blue, it's E to the x. So when you want to get the blue stuff, you hit second and then that. If you just want E and you're not raising it to a power, you also can do second and then the division button. Because if you look above the division button, you can see a little blue E. That's if you don't want to raise it to power. Most of the time, though, we're raising E to power if we're using it. All right, we also have logarithmic functions that are log base E. And log base E are called natural log or natural logarithms. And the abbreviation for natural log is Ln. So f of x equals Ln of x. Why do you think it's Ln and not NL? So are any of you taking a foreign language? Spanish, French? Okay. When they describe, do they do adjective noun or noun adjective in other languages? Would you say natural log or would you say log natural if you were speaking Spanish? Log natural. Most other languages like Euler and I don't know how you say that, Bertoli or whatever. They're not. They didn't speak English. They're from other places, and so most likely it's Ln because it's really log natural. The other languages, but there's also an Ln button in the calculator. The Ln button in the calculator just looks like Ln. It's right. It's kind of like beside the 7 and the 4. So when we need to do the natural log in the calculator, we'll just hit that button. We don't have to put a base. It's automatically base E if it's natural log. Okay, so just like we did on the quiz yesterday and the last few days, we can go back and forth between logarithmic form and exponential form. So if the base is E and we want to go to logarithmic form, it's automatically going to be Ln. So you don't do log base E. you just do ln. So if we have e to the x equals 24, it's going to be ln. What would we write next if we were like going around the loop? So ln takes care of log base e, not x. Ln of 24 is equal to x. All right. So when we're writing in logarithmic form and it's the base is e, we just automatically do ln. So that takes care of log base e. And then we can do the loop. So natural log of x equals 9. All right, you guys go ahead and try 3 on your own, please. All right, so because base is e for the logarithm, we do ln, and then we can do the loop. So natural log of 72 equals x plus 5. All right, any questions so far on that? So it's just a little bit of a shortcut. You don't have to write log base e, you can just write natural log. All right, and then for number 4 through 6, we're going to do the reverse. So we have it as a logarithm, and we're going to write an exponential. So anytime you see ln, it's base e, so we'll do e. Which one of those is the exponent, the 58 or the x? The 58, and it equals x. So we can think of that as an e. E to the 58 equals x. All right, if we do number 5, same thing. Natural log means the base is e. All right, and if we went around, e to the x equals 6. It also helps to always remember that a logarithm equals an exponent. So if it was over here, that means it's going to be an exponent. All right, you guys try 6 on your own, please. So it should be e to the 32 is equal to x minus 9. All right. Then the last 4 examples are going to be solving equations. Sometimes we're going to solve logarithmic. Sometimes we're going to solve exponential. We're going to use the exact same rules that you guys used on your quiz yesterday. So 7 and 8 are logarithmic because that's the ln. ln means log. And there's 2 things we do for logarithmic. We're either going to drop off the logs or we're going to write in exponential form. What are we going to do on 7? Drop off the logs. So if you have 2 logs, log equals log, we're going to drop the logs. What about 8? We're going to drop the logs or exponential form? Exponential form. You have to have 2 logs to drop them. So if you only have 1, we're going to write it in exponential form. All right, so let's start with 7. So I'm going to drop the logs, and that gives you 4x minus 27 equals 15 minus 2x. And then from here, it's just solving the equation. Personally, I like to get my x's together first, but that's up to you. So when I add those x's, I'm going to get 6x minus 27 equals 15. Right, and then from here, it's 2 steps. 1 step's to add. And then 1 step is to divide. Oh, wait. All right, and then it does tell us to check for extraneous solutions. We really only need to do that on the logarithm, the log equations. Because it's possible when we plug this back in, the calculator would give us an error. I think it's okay though. All right, so since it's ln, I can just hit the ln button beside the 4 and then do 4 times 7 minus 27. All right, I got a 0. Let's make sure I get, let's make sure I get 0 on the other side. ln 15 minus 2 times 7. And I did. So it checks out. It is an answer. All right, so let's go to number 8. So number 8, we already said we're going to write in exponential form. So in exponential form, the base is e. What's the exponent on this one? 2. And that should equal 8x. All right, and then we'll go to the calculator to see what e squared is. So remember, e is going to be second ln, and then we just raise it to the second power, and that's it. Right, and then we'll divide that by 8. So I wouldn't do the rounded number divided by 8. I would just divide the number in the calculator. So when you hit divided by, it takes that whole decimal and divides it by 8. And that should be all right. Okay, now when we check our answer, it's not going to give us exactly 2 because we're rounding to get it. A little bit of a hesitation. There we go. So it's close. It's close enough. That is right. All right. We're also going to do a couple of exponential equations. So remember, when we're solving exponential, the first thing we want to do is get the exponential expression by itself. So that's going to involve some addition, subtraction, division. I don't know. I know on number 9, I'm going to need to add 6. All right, now e is that irrational number. There's not going to be, it's not like 8's not going to be some kind of power of e exact. So on all of these exponential equations that have e, you're not going to try to write with the same base. You're just going to write in log form. So isolate the e to the power and then write in log form. So because the base is e, like we're going to do the exact same thing we did on 1 through 3. But since the base is e, we're going to use natural log. and then you can do the loop if you like it. So the natural log of 8 is equal to y plus 3. The natural log of 8 we can get from the calculator. All right, so this gives us what y plus 3 is. To get y, we would just subtract 3. And again, I would just use the whole answer in the calculator. So I would just do minus 3. I'll take that whole number, subtract 3 from it, and then round that one. Hey, Grandma. There we go. Now you can check your answers on the exponential if you want to, but if you do everything right on those, it's going to be right. All right, and then number 10 is just a little bit more difficult. Sure. Number 10 is going to be a little more difficult at the beginning, but it'll be the same at the end. All right, so I need to get the 7 and the negative 2 away from the e, and these are always kind of tricky, but because this 7 is positive, to move it over, we are going to subtract it. Okay. And then what do you guys think we do to get rid of that negative 2 in the front? Divide by it. You maybe can figure this out in your head. You guys know e to what power gives you 1? Yeah, some of you know. All right, if you don't know, it's okay. We can write in logarithmic form. So since the base is e, it's the natural log of 1 equals x. All right, that's going to be 0 because I moved it too fast, sorry. Because everything except 0 to the 0 power is 1. So if we're looking for that, it's definitely 0. But if you didn't notice it, it's okay. You can do the whole problem. All right. So what questions do you guys have about E? It should feel pretty much like what we've already done. It's just for E, it's always ln. Okay, so your assignment is the back.